Morning, everyone. Can you all hear me okay if I speak like this? Okay, great. Yes, I'm Tim, and yeah, I've come all the way here today from Canberra in Australia. This is my city here, looking nice and pretty. And yeah, I help run IceLab, a design studio based in Australia. This is my team right here. There are 16 of us. We work together, and some 8 or so of us do Ruby development day to day. And yeah, I'd like to thank IceLab for getting me up here for this conference. It means a lot for me to be here and share some things with you all. I'd also like to thank my other very important sponsors, my family. They've made it possible for me to put the time into making all these things I want to share with you today, so I am very grateful. Now, out in the Ruby world, you might find me in places like these. I'm a core team member on the DryRB and the ROM-RB open source projects. And now, while I'm in the process of making shout-outs, I thought, being an out-of-towner, I should probably do the right thing and maybe pay homage to a local sports team. So did a bit of research, and before too long, there was really no question which one I should shout out. So go you Nashville Kangaroos. I was quite surprised to find the Aussie spirit alive and well here. Speaking of sports, it's great to be here in the USA, the home of the Dream Team. You know what I'm talking about, right? The podcasters of my dreams. Seriously, though, it is an honor to be part of this lineup here. It's an amazing bunch of speakers, and so much great Ruby stuff comes out of the United States, and I am honored to be here and contribute a little back via this event. So thanks, Jason, for encouraging me to get up here. So my talk is a mystery. I am TBA on the schedule, and I kind of like this. So I'm going to keep you in suspense just a bit longer, because before we get started, I want to talk a little bit about classical art. So here's a painting for you. This one's from 1893, and that's a pretty harrowing scene, right? And here's the title: Programmers at Work Maintaining a Ruby on Rails Application. Oil on Canvas. Now, this is actually from a very amusing Tumblr called Classic Programmer Paintings. And for this one, for someone who's worked in Ruby for a long time, boy, it really hit close to home. I mean, just look at her eyes. She's seen some things. She barely made it out of user.rb. And I think this hits so hard because a lot of the time, for a language that aims for programmer happiness, my work maintaining apps really felt quite a lot like the opposite. Once apps reach a certain size or a certain age, my efforts in maintenance and feature development, they slow to a creep. Everything feels too tightly connected. Changes in one place would cause issues in another, and every change just took a bit longer than the one before. And yes, starting fresh on new apps from time to time, that might be a reprieve, but it's short-lived, and repeat this cycle for long enough, and it's enough to make you want to give up, or perhaps more likely, look to a fresh new language as if that's going to solve all your problems. Well, turns out a lot of thinking has gone into this sort of problem, and in fact, the luminary of our industry, Martin Fowler, has wrapped it up quite nicely in what he calls the design stamina hypothesis. And this lets us chart out our work effectiveness over time. So that harrowing looking picture from before gets summed up nicely into a line like this. At the beginning, when we're working on an app, we build things really quickly. We're feeling good. But then over time, it flattens out, and our ability to deliver new work becomes less effective. And this is what happens when we build an app and don't end up putting enough thought into its design. And yes, the Rails way is no remedy for this, and many would argue it gets you to this point even more quickly. And this here is the line of the sad, tired, frustrated developer. And that's the line I know I sat on for far too long. Whereas over here, we have this tantalizing red line. Now, this one takes a bit of time to ramp up, as you can see, but then it shows the work on our apps continuing at a nice, steady clip at a sustainable pace. And this one's the line of good design. It's a line that shows what can happen when we make the decisions that will allow us to more cleanly arrange all the elements that will go into our work. And this is the line of the happy developer, the empowered developer, someone who can go in, day out, and deliver effective work. So when we consider these two lines and look at where we intersect, we see this design payoff moment, or as they say it now, the life comes at you fast moment. This pretty much is the point in time after which you wish you'd made some better design choices. And this moment happens way faster than we realize. And so what I want to show you today is one way to move from that bottom line to the top line there. So I tried to make this jump myself because things didn't feel right. Like, this wasn't the way I wanted to program. So I tried a good number of times in the past, and I thought what would get me there is by following those good object-oriented design principles. Those are the things that should guide us as Rubyists, right? I know I'd watch all the talks about these sorts of things, and I'd see all that nicely arranged code, and I'd get fired up, and I'd say, yes, this is how I'm going to make my apps. But then I'd go back to those apps, and I'd really struggle to apply those principles to my actual living code. They were almost taunting me. And I'd find myself in this gap between my desires and my reality, between the way I wanted to write my code and the way my tools seemed to be encouraging me to write my code. And I couldn't find a way to bridge it. Well, as you might guess, I did finally find a way out, and it happened by following an entirely different approach. So everybody stand back, because I want to tell it to you now. Here it comes. Functional programming will save us. Rejoice! Scratch Haskell, maybe write Elm. That would be the topic of the moment. But no, I'm not really suggesting we all jump ship. This is a Ruby conference after all, and here we finally make it to the title of my talk, Real-World Functional Ruby. And I want to show you how we can take a functional approach to writing apps in Ruby and how it can actually help us make better real apps even today. So to start with, why functional Ruby? Well, this is why, right? We're falling behind. We've got to stay on trend. And functional programming is hot right now. And we're here in Nashville after all. You all know about hot. But when it comes to functional programming, I think it's hot for good reason, because it gives us clarity in understanding how something is pieced together. It can let us easily understand the flow of data from place to place. And the approach gives us a manageable way to build large things out of smaller pieces. So why shouldn't we do this in Ruby too? It's a flexible language after all, and is actually not too far removed from some of these functional concepts. So if we want to make this move, I think the first step we need to take is a change in mindset. It's about viewing our app as a series of transformations. Data goes into our app, in many cases an incoming HTTP request, for example, and then it gets worked on and transformed over a number of steps, and then out the other end we get our result, or our HTML. So if we think about an app modeled as a series of transformations, it's really an app modeled as a series of functions. And this is where we get to the functional part of functional Ruby. We can model these nicely as functional objects, and I want to take a look and guide you through all the properties of one such of these objects right now. So today we'll be making an import products class. So if we were building some kind of online store, we'd use a class like this to populate our own product database from some sort of third-party feed of product information. And even in the lines we see right here, we see the first quality of a functional object. It can so often be named by a verb. It's a verb because it represents an action we want to take, a transformation we want to make with regards to our products. And then it has a call method, just like Ruby's own language level functions, blocks, procs, and lambdas. And occasionally we might want an object with a few more methods, but a lot of the time, call is all we need. And then we want this method to accept an input, go to work, and then return some output. And along the way, it shouldn't mutate the object's own state, and it shouldn't mutate that input data either. And this is one of our big departures from a classical object-oriented approach, because functional objects separate data from behavior. They don't keep that input data anywhere in their own state. And we use that state for something much more interesting. We're going to keep the object's dependencies or static configuration there. Those are things that never need to change. And effectively, this makes our functional objects immutable. And it's a big part of the design approach we'll be taking. because by making our functional objects immutable, we take away the whole dimension of time when it comes to understanding them. We know that once they're created with a certain state, that's the state they'll keep wherever they're used and wherever they're passed around. And this goes a long way to improving the overall simplicity of our apps. Now, before we go any further, let's take a quick look at what this call method is actually going to be doing. So it's going to get a list of that product information by downloading the feed. And then it's going to work with a product repository and loop over all the third-party products and create a copy in our own database. Now, this is a pretty clear and simple method to read. And that's because it's delegating a lot of work to some dependencies. And this is what allows us to break our objects down into smaller, more usable, and easier to understand units. So here are those dependencies: download feed and the product repository. And here, those dependencies show the next trait of a functional object. They get passed in via the initialize method, and then they're captured in the object state. And yes, once they're there, they never need to change. And what we're seeing here is, of course, constructor dependency injection. And that's another classical object-oriented design technique that actually works to great effect here with these functional objects. And the result is that we can create our object just once, passing those dependencies in, and then we can call it many times over with different inputs and in varying contexts. And once it is constructed like this, it can be passed around too and go on to be a dependency of other objects in turn. Now, after going through all of this, you might be thinking that what we're really looking at is just one of those service objects that we pepper around our apps when we feel like we need some extra complexity to be handled. And you're right, this is exactly true. But what I'm suggesting is that we use this approach to model the entirety of our application's functionality, because we want a comprehensive and consistent design approach, something that lets us follow the same steps in every case. So all of the CRUD actions that we're used to building, well, they can be functional objects too, organized like this in modules, so they're kind of grouped by their context. In fact, every single piece of behavior we want our application to offer can be expressed in this same way. And the more complex the behavior, the more likely we will want to break it up across multiple functional objects, which we can then bring back together and orchestrate at a high level. So that's how we take care of the behavior side of things. But how do we handle our data? Well, we can do this courtesy of types, and this is Ruby, of course, so it's not the capital T types we just saw in Elm. But what I'm really talking about is modeling our data as value objects. And a value object is an object that holds a particular structure of data from our application's business domain. And just like our functions, we treat these as immutable. Once they're initialized with that data, they should never change. And of course, we can add behavior to these in the typical object-oriented style, with extra methods working with the values we already know we have. Now, if you're used to working with active record classes as the nouns in your application, well, do take note, because these are more or less the complete opposite. They're inactive. And the nice thing about this is that we can now easily pass them all around our application without having to worry about unexpected mutations or behavioral side effects along the way. And this allows our value objects to become first-class objects within our system. All of our functional objects can now depend upon and work with these structures. So in a Ruby app built in this style, our objects tend to break down into these two categories: values and functions. Values hold data, functions operate on that data. And the values, they're inert, they're passive, whereas functions are active. They go to work on those values. And if the values are the content in our system, the functions form the pipeline through which it flows in order for us to achieve some sort of outcome. So that's the functional design approach summed up. We take these two elements, functions and data, and model them both as Ruby objects. And we do use objects because Ruby is still at heart an object-oriented language. So we should acknowledge here that what we're really doing is creating a blend, a hybrid of functional and object-oriented programming. But in doing this, we escape many of the pitfalls that those object-oriented design principles are there to help us avoid in the first place. Because if you look at them more closely, our functions already satisfy so many of these principles right out of the box. They're already single responsibility. They're already open for extension but closed for modification, and they're built from the ground up to prefer composition. So our functional code ends up being better object-oriented code too. And we've done this with a really blindingly simple approach that doesn't leave us wringing our hands at each point over how best to conform to all of these principles. And the approach we're taking here is confirmed by the ease of testing too. So we'll take this class we've built, this import products class, which needs to interact with those two different external systems, the remote products feed and our local database, and then write a standalone unit test for it. So we start by recalling our dependencies. Here they are, download, feed, and product repo. And each of these is what represents our interactions with those external systems. So then we can set them up as test doubles or mock objects. And then we set up our subject, our unit under test. We create our import products object by passing those doubles in to the constructor. And then we create a real feed object to act as our input value. And then we do one more thing. We set up our download repo double to return local fixture data whenever it's called with that feed. And with that in place, we can now call our importer and assert that our repository had been asked to create a record for each of the books that we knew were in our local fixture file. And that's it. And we could use those test doubles so easily here because we designed those functional objects to work with these abstract injected dependencies. So instead of having to interact with two different external systems, the third-party feed and the local database, instead we could just simulate their behavior and focus on our one function and test it quickly and in true isolation. And the more we test like this, the fewer of the big, heavy integration tests we need. They're still important, but they become more meaningful because they sit there really, truly to test that integration. So if there's been a strong theme so far, it's been about making our dependencies clear. And I think this because it's one of the best things we can do to enable well-designed code. Once our dependencies are clear, we can really easily recognize that our app exists as a graph of objects with the classes or objects as the nodes and those dependency relationships as the edges. And if we take an extra hard look at those edges, at those dependency relationships, we can get a sense for how well designed the app is overall. Because if they're arranged like this, so everything's flowing in the same direction, this is called a directed acyclic graph. If our app looks like this, it's a good sign it's going to be easier to change. On the other hand, if our graph showed the edges flowing in different directions or being cyclic, then that's a sign we could be in trouble and we could encounter some more difficulties when it comes to change. And that's really why we take the time to establish this approach in the first place, because good design makes change easier. And good design is what gets us onto that happy upward slopey line of continuous, steady feature delivery. And as it turns out, a functional approach to design gives us all of this, and it does so in a way that's really easy to follow, based around that widespread use of functional objects and clear composition of their dependencies. Now, I know what some of you might be thinking right now. This is some charlatan standing before you, and it's one weird trick that'll fly fine for a conference proposal, but it'll never work in the real world. It's not practical. You couldn't do this for a whole app. Well, I am happy to say this is no weird trick. It really does hold up to real world use. And this is an approach we experimented with at IceLab where I work, and we liked it so much that this is now our preferred way to build any Ruby application. And over the last 2 years, we've shipped more than 10 apps like this across different domains and with varying levels of complexity. And each one of these apps was only built by teams of 2 or 3 people, and those people themselves had varying levels of experience in Ruby, and all of them learnt this on the job. So this is an approachable way to do things, and we still managed to get things done. So if this is sounding attractive to you, or you don't have to worry about going out on your own and forging your own path towards this kind of architecture, because we now have a whole Ruby ecosystem that's grown up around this approach. And I want to take you through a quick tour of some of it now. And most of what I'll show you comes from the DryRB open source project. And we started this some 2 years ago, and as far as I'm aware, this is actually the first time it's been introduced at a major conference in the United States. So this stuff gets me excited on an ordinary day, but to share it here with you today, it's really special. We have a good bus number. There are 6 of us on the core team, so you can relax. And what we're doing together is making a collection of what we call next generation Ruby gems. And we call them this because, yes, they're informed by the lessons we've learned in building apps over many years, but they're also our concerted attempt to nudge our ecosystem in a better direction. And each gem solves a single problem on its own, and you can use it on its own. But you can also bring them all together if you want to form a full web stack, which is what we did to make our apps at IceLab. And in fact, many of these gems are built specifically to support and encourage this functional design approach we've been looking at. So they're the ones we'll explore today. And the first category of gems I want to show you are the ones that help with dependency management. Now, you might have been wondering, how exactly do we get around to initializing all those functional objects in the right place and at the right time, and then orchestrating the passing in of all those dependencies, especially when our apps are going to have hundreds or more of these things? Well, for this we have some gems to help. We have dry system and dry auto inject. And our first step towards doing this comes from dropping dry system into place. And it offers us a centralized container for accessing all the objects in our app. So when we boot an app using dry system, we can have it populate its container using a very simple approach. It starts by scanning our source files, like this one. And then for each file, it'll register a matching identifier string. And it'll do this until we have an identifier for every single functional object in our application. And then with all this done, we can hop over back to our class file. And now we can add this auto injection mix-in where we simply declare the dependencies we want to work with. And we refer to them by their container identifiers as well. And this takes care of all the dependency-related boilerplate we had back in that initial example. So the initializer, the instance variable assignment, the attribute readers, they're all wired up now. And this will actually do one more thing for us too. Because now when we go back to our container and actually retrieve that object, we get back something that's pre-built, ready to use, with all those dependencies resolved from the container and automatically provided. So that's how dry system does its thing. And all of this, it resembles maybe the auto loading that you're used to in Rails apps, but it does it using very basic language level features, just require and load path, and that's it. So it's deterministic and easy to understand. And with this in place, it actually becomes really manageable to build an app out of hundreds of objects like these. And it also becomes really low friction to extract out behavior and move it into a new object, which you can then pull back in as a dependency if you ever see the need. Just one more thing on this though. While that auto injection is definitely helpful and the convenience we need to do this in a widespread way, it doesn't mean we give up control. We can still choose to provide our dependencies manually wherever we want. And this is quite helpful for testing because sometimes we might want to use a mix of dependencies with some of them remaining as the system defaults and some of them being our test doubles. So if we did this in this case here, this is going to give us a less isolated test because it's still going to hit our product database. But it does make certain kinds of testing much more practical. So it's good you have the option to do both. All right, the next thing we come to is result handling. This is the thing we need to worry about once we actually call our functional objects and work with whatever comes out the other side. And we can make these objects much more flexible if we make it so they all return the same kind of output object. And yes, I'm going to say it, we're going to turn to monads for this. They're another element from functional programming languages. And Ben already touched on these this morning when he talked about the maybe type in Elm. Well, with dry monads, we can have this in Ruby as well. So we can make, like this morning, our own maybe age object. And it can hold a real number like this, or nil. And because we know this is a maybe, because it's going to be wrapped up like this, we're forced to go through safe APIs to ensure that our number operations only run correctly when a real number value is present. And we can also use these monads to wrap up the return values from our functional objects and to signal whether their operations succeeded or failed. Now, without looking any further into those, even just having this consistent result object allows us to provide something really nice, like this result matching API from DryMatcher. And this lets us just as easily act on both the success and failure outcomes from a call to any functional object. And in looking at this, you can see how we're improving the robustness or correctness of our apps because we elevate failure handling to be a first-class concept. Failures are handled in the very same ways we handle successes, and matcher blocks like these won't even run unless we have all the cases covered. Okay, so we've powered up our functions now. But what about the other half? Our values, our data? Well, we have you covered here too. We can start by looking at dry validation, and it lets us model our validations with precision and safety and work with any kind of data. And it's based around standalone validation schemas. And this means they can be tailored to suit each specific use case in our applications and put as closely as possible to the boundaries of our applications. And what they do sitting there is they ensure only valid data makes its way into the application's core. And then for the structures that exist in the core of our app, those values we want to pass around between all our functional objects, we have dry types and dry struct. Dry types helps us identify, name, and reuse common data types within our application and supply things like constraints and coercions. And then dry struct helps us define strictly typed value objects, consisting of multiple attributes along with their own corresponding dry type signatures. And using this means we can now become completely confident in the shape of the data we're going to be working with and passing around our app. And we'll notice very quickly if we ever encounter the data that doesn't match our expectations, because it'll blow up. So the building blocks for our functions and values, they're looking pretty strong right now, but there's still a bunch of things we want to do if we want to extend our approach to cover building entire web apps. So let's talk about views. For this we have dry view. And dry view lets us build our views as functional objects as well. So we get full support for those auto-injected dependencies, and this lets us cleanly connect our views to the parts of our app it needs to work with. And then we can explicitly expose data to our templates, and then also wrap up that data in custom view part objects for providing properly encapsulated, reusable, and testable view logic. No more mess of helpers. I really like working with dry view because so often the server-rendered view layer is where good design just falls apart. But now we get to extend the same design approach all the way out to our views. All right, we're rendering views. How do we get them to the user? Well, we need to take care of HTTP and routing. And for this, we have dry web rotor. And this is a very small gem. And all it does is integrate dry system and dry view with Jeremy Evans's rotor web framework. And it makes it very easy to do the things we need to do in the HTTP layer, like fetching and rendering our views, and then calling our functional objects, and then responding to their results. And in the end, this ends up being the only layer in our entire app where we have to deal with HTTP concerns. And it leaves the core of our app to focus on its own job without being muddied up in any way by leaking HTTP logic creeping all the way in. Dry web rotor also has a project generator, so you can run that and get started with a new app for building something with all these gems brought together. And then we come to the last thing, the last big missing piece, and that's database persistence. And for that, we can turn to ROMRB. It's another open source project, a sister project to DryRB, I would say, because it shares many of the same philosophies. And it's also designed along functional lines and integrates perfectly into apps built with Dry System. And ROM gives us APIs to cleanly access every part of our database. It helps us embrace our database and put it to work for us, just like Harish Shankar's advice yesterday. But what it also does is help hide away that persistence logic from the rest of our app. Because when we work with ROM, we build up these dedicated repository classes that serve as our only interface to persisting data. And then these return properly typed value objects that we can tailor to suit our application's business domain. So that's how it all fits together. And so looking at all these gems, what have we done here? Well, we've satisfied pretty much everything you need to build a complete working web app in functional Ruby. And along with this, we've satisfied these requirements using tools that encourage these good design choices along the way. And for me, it was working like this with these tools that finally made me feel like I jumped that gap. And I don't know whether this qualifies as good code, like we were thinking about yesterday, whether this makes me a liberal or conservative, I'm not sure. But all I know that I was finally building things that felt solid from start to finish. And I found myself being able to continue working on my apps at a much nicer, steadier pace. I'd finally hopped to that red line, and there I found myself a happier developer again. And in fact, honestly, it was entering this community of tools that was the moment I rediscovered joy in Ruby and made me happy to be here again. And I owe it all to that ecosystem of tools for making this approach the easy one and the natural one to take. And I'm really excited right now because this idea of functional Ruby is moving beyond just a small set of tools. I think we're starting to see the beginning of a functional Ruby movement. And we can see this through a growing number of projects that are all starting to gravitate around the same ideas. Yes, we've seen DryRB and RomRB today, but there's more. There's Trailblazer, for example. It offers high-level business logic architecture for Ruby apps, and it works with any kind of web framework in Ruby. And as a project, it's been around for a long time. But with their 2.0 release in the last year, they've adopted a real functional Ruby approach too. They offer operation objects that come with some really advanced flow control behaviors. And they fully support dependency auto-injection and integration with apps built around containers like DrySystem as well. And then we have Hanami. It's a modern, fully integrated web application framework. And as of this year, they've made it to a really important milestone. They've hit 1.0, so it's really ready for you to use right now. And it's also oriented around single-purpose, stateless objects for all the various components that you might need in a web application. And there's some really interesting thinking that's already started around Hanami's 2.0 evolution. Just a couple of weeks ago at the Rails Club conference in Moscow, Luca Guidi, the lead developer, he shared how they'd like to take things in an even more functional direction, basing the framework entirely around functional objects like we saw today, and building up processing pipelines for handling web requests. So all of this makes me feel that the Ruby community is ready for a change like this. All of these groups are working hard and working together to make this happen. As Victor Hugo said, there is nothing more powerful than an idea whose time has come. And I did joke earlier about functional programming being hot right now, but yes, and it's fun to poke at the flightiness of programming trends, but I really think this is trending right now for a reason, because it's an idea whose time has come. The world and our tools are ready. Again and again, through the history of invention, when we see that the world is ready for an idea, when those foundations have been laid, that idea won't come to just one person. It'll come to numerous people in numerous places. And when that happens, just like we're seeing with functional Ruby, then you know it's an idea worth paying attention to. And in this way, I think we're starting to bridge a real gap that's for a long time existed within our own community. I certainly haven't forgotten how much we owe to Rails. It's the thing that got most of us our jobs, and ultimately it brought us all here today. But for the longest time, I think Rails has been perceived as the start and finish of the Ruby story. So people who wanted something different didn't really have a place to go. And people who felt like they wanted something different, well, they didn't know where to look. And now we're starting to see such a place form around these communities and these tools. And this makes functional Ruby a real-world thing. And as we've seen today, it's something that can bring improvements to each of our real worlds as app developers. Because when we follow that hybrid of functional and object-oriented design approaches in Ruby, we really do strike this amazing balance that helps us build better designed, more maintainable applications. And then, when we take this formula and add in our Ruby community, this generous, welcoming, thoroughly decent community of ours, things get even better. Because here we're all about making technology approachable and fun, regardless of the paradigm. We want to help people level up. We don't put barriers between people and the things they want to learn. And with Ruby and all its flexibility as our community's shared mode of expression, well, there's really nowhere we can't go. And if functional Ruby is a place you want to go, then trust that you'll be supported. Projects like DryRB and RomRB and Hanami and Trailblazer, they're all here to help. You can also feel confident that it's a thoroughly practical choice to explore these concepts from within Ruby. Not only because Ruby is a pragmatic, flexible language, it'll still help you get things done, but also because it'll help you continue to leverage all of that existing knowledge you've built up of the language and our ecosystem. So I think this makes functional Ruby worth a real try. It can help you make better apps, and it can help expand your mind at the same time. And if you'd like to to join me, I suggest you check out this repository on GitHub. We're just getting started in building a best practice example app with the DryRB gems, so now's a great time to start watching and following along. And I've also gathered up some notes about this talk on this link here, so you can refer back to any of these later. And with that, thank you so much for your time. I really hope you'll give this a chance the next time you think about the way you build your apps. Thank you.